Hello again, Meridian. I hope you all had a good break. Our quiz question was, what was the memo on the first ever transaction on the network? And the answer is, and I'm guessing all you CS majors out there got it right, hello world. The Stellar network launched in 2015 with first transaction with that memo. It has since processed over 1 billion transactions. So we started the day hearing about the nodes that make up the network, and those nodes all rely on a common protocol to interact. That protocol, however, is not a static thing, right? It evolves, it gets new features to meet the growing needs of the ecosystem. Generally, those new features are introduced in major protocol upgrades, which validating nodes actually vote to accept, the same way they vote to accept transaction sets. The protocol 15 vote, upgrade vote, it's in a week. It's a week from today. And a quick aside, if you haven't already, please make sure to install up-to-date versions of any and all Stellar-related software that you use. Otherwise, you will be experiencing difficulty. Had to get that in there. But now, what goes into the making of a new version of the protocol, and what can we expect from Protocol 15? Our next presenter, Jon Jove, Senior Engineer at SDF, will answer those questions and more as he explains how protocol upgrades foster the usability of the Stellar network. Jonathan, thanks for being here.
Thank you, Justin. I appreciate the introduction. So as Justin said, my name is Jon Jove. I'm a senior software engineer at the Stellar Development Foundation, and I'm responsible for protocol development. So today, I'm going to talk to you about some recent protocol upgrades, how they've helped foster the usability of the Stellar network, and some future upgrades that they enable. These aren't upgrades that we're necessarily going to do. Rather, they are potential changes that we might make, and I'm telling you about them to help stimulate new conversations about what the protocol could be and what its future might be. So with that out of the way, let's get started and talk about two-part payments. So two-part payments, I'm extremely excited about this feature. To me, they represent a huge step towards achieving our vision that money should move like email. But right now, you're probably wondering, what is a two-part payment? And why would I prefer a two-part payment over a payment, or what in this context one might call a one-part payment? And to really understand the answer to that question, you really have to understand the difference between what a payment is on Stellar and what a payment is like in cash. So let's take an example. Suppose that you go to dinner with a friend, and the restaurant doesn't like to split the bill because they're trying to avoid punitive credit card transaction fees. Reasonable. Your friend offers to pay it. That's nice. But you are not a moocher, and you want to settle this bill as soon as possible. So you think, how could I do this? Well, you know that you and your friend both have Stellar accounts, so you know you can do it on Stellar. And you also know that you have some cash in your pocket, and hopefully you have the right amount, and you could settle it in cash if you had to. What might happen if you tried to settle it on Stellar? Well, you'd send a payment, and most of the time that would work. But it's not guaranteed to work. And that's one of the important distinctions here. It's possible that the payment could fail because, for example, your friend doesn't have a trust line for the asset you're trying to send. In other words, your friend is saying, I can't hold that asset. But what would happen if you tried to pay your friend in cash? I don't know your friend, so I'm not 100% sure about this, but I feel quite confident that your friend is not going to say, whoa, I can't hold that cash. That sounds pretty ridiculous to me. So the big difference between making a payment on Stellar and making a payment on cash is that a payment in Stellar could fail because of the state of the recipient account. So you might prefer a two-part payment over a one-part payment because two-part payments reduce friction by making it so that payments do not fail due to the state of the recipient account. But I still haven't told you what a two-part payment is. So let's get into the details and talk about that. So based on the name, you might have expected that a two-part payment takes two parts. It has two steps. The first step is what we call create claimable balance. It's a new operation that's coming live on the network in Protocol 15. And when you use this operation, you won't actually send a payment directly to your friend's account. You'll create what's called a claimable balance entry. And a claimable balance entry has some data stored in it. It has an asset and an amount. In this case, you can see on the right, it has $100 in it. And it also has a list of claimants. And the way that you should think about these claimants in the claimable balance entry is a claimable balance entry is like a lockbox. And every claimant has a key to the lockbox. So in this case, we're saying that B has a key. And you see underneath that we have the predicate. Now, in this case, the predicate is unconditional, but more generally, the predicate is something that controls when the key works. For this simple case where we're just trying to make a payment that doesn't fail, we don't need that, but we'll talk about it more soon. Now let's look at part 2. Part 2 is receiving the payment. So to receive a payment, a two-part payment, I should say, the recipient would use what's called the claimable balance operation, another new operation added at the same time. And here on the left, we have the same claimable balance entry that we had at the previous time. Whenever B is ready to receive this payment, whenever they have the appropriate trust lines and whatever they need, they just use this operation, they get their money. Now, if they happen to use it at the wrong time when they're not able to do it, nothing bad happens. They just try again, no problem. So this adds an extra step, but makes everything a lot easier to think about. Now, what about these predicates? Why do they exist? Clearly, you don't need them to achieve the original goal of making it so that payments don't fail. But when we make changes to the protocol, we're trying to make changes that are either super specific and solve a very, very specific problem, or we're trying to make changes that are highly generic, solve a lot of problems all at once. We prefer to do that when we can. A lot of times, things that look like they're going to be the first thing become the second thing. Predicates are an example of that. So we added these predicates because of the new generic features that they introduce. So let's talk about what those features actually are. So for me, the predicates represent this ability to add new payment primitives to Stellar. One of those payment primitives is what I would call a cancelable payment, a payment that can be canceled. Why might you even want this? Like, why is this a useful primitive before I tell you about how it works? Well, the answer to that is blockchain can be kind of scary because the most important thing about blockchains is that they're immutable and transactions are irreversible. This is why they're powerful. But the problem with that is there's nobody to rescue you if you make a mistake. If you send a payment on Stellar and you accidentally sent it to the wrong person, you can't call up Chase or Wells Fargo or BNP or whoever your bank is and say like, oh, please, I made a huge mistake. Can you undo this for me? They'll just laugh at you because they can't. Nobody can. All you can do is ask the person who received your money to send it back to you. Maybe they're nice and they'll do that for you, but probably not, realistically speaking, because they have your money now. So that's pretty scary. And so cancelable payments give you a chance to check that you didn't make a mistake. And so here, let's talk about how this actually works. So we create a similar claimable balance entry. It has $100 in it. And once again, B has one of the keys. But B's key will only work starting tomorrow. Now, who has the other key? A has the other key, the sender. And A's key will work until tomorrow. So you send this payment, then you get to look at what you did. If you made a mistake, you just receive the payment yourself because you have that opportunity for the first day. No mistake, you do nothing, and B can receive it tomorrow. All good. Now, this protects you in case you make a mistake. But you're not protected in case B makes a mistake. But these new payment primitives will also let you do that. So another payment primitive you could build is called a recoverable payment. And a recoverable payment is basically a payment that you can get back some date in the future if the recipient didn't claim it. Now, why might you want this? Well, imagine you send money to some other party, and in between when they billed you and when you sent the money, they accidentally lost their keys. This isn't really far-fetched. This basically happened to me with a contractor, not on Stellar, a few weeks ago. So this is something that really can happen, and it was a big mess to try to figure out how to get that money back. Now, on Stellar, you wouldn't have a lot of recourse if something like that happened. But a recoverable payment, well, if they lost their keys, they wouldn't be able to get the money. And so then you could just turn around and get it when it expires. Here, I have it set for a year, but you could set it to a week, a month, a day, whatever makes sense for you. The point being, this is flexible, and it protects you against your destination's mistakes. Now, these are just two examples of new primitives. You could build more complicated things. You could build a cancelable, recoverable payment. You could build a payment that has many more claimants if you were, for example, paying to a couple, like a married couple. But the only restriction on all of this is that right now, all the predicates are time-based. Now, that sounds like a big restriction, but really they cover a lot of important use cases. But more importantly, the design makes this really, really easy to change. And that was a key design goal, that these predicates should be highly extensible. So here are some new examples, some examples of new predicates that we might add in the future. We might add a predicate on the ledger sequence number. This is a lot like time, but maybe it would be useful in some cases, but it's just to give you an example. We might also add one on the account sequence number. This could be a useful contracting primitive because it means that if you've executed a certain transaction, it becomes impossible to claim the claimable balance entry. So that's just another example of what you might be able to build. You could also use a predicate on the balance of an asset that a certain account holds. This basically turns holding that asset into a key to a lockbox. Whoever owns the asset owns the lockbox. But beyond all of that, you might add something even more abstract, like revealing information, the pre-image of a hash, for example, when you claim something. These are all different things that we could build, just examples. The point is that these are easy things to do because of the feature, the way that we built it. So if you have a good use case, you should reach out, let us know, and we can probably help you out. Now, that's an example of something that we really designed to extend. But one thing that claimable balance entries and two-part payments enable is solving a problem that I've seen discussed on the Stellar Dev mailing list and in the protocol repo many times. And this is the problem of merging a trust line. You might encounter this problem if you're trying to use, for example, an escrow account. And the escrow account holds some non-native assets, let's say USD, because I'm American. And at the end, you have to close out that escrow account. But ideally, you've probably agreed in advance how to close out the escrow account using pre-signed transactions. Now, this presents a problem because if you want to make a payment to close it out, you have to know what the balance is in advance, and also the payment could fail. So merge trust line, this kind of concept, basically, it should be a never failing operation that allows you to close out a trust line entirely. Now, to do this, what we would do is basically create an operation called merge trust line that takes a trust line and just directly converts it into a claimable balance entry. Now you've basically achieved both goals. Because it's a claimable balance entry, a two-part payment, you know it won't fail because of the destination, and because it's using this merge functionality where it takes the entire balance, you know that it's not going to have any issues with, well, what is the balance? But this is just another example of what we could build using these features that we've already added. Now, that's enough for me about two-part payments. I want to move on and talk to you about another really exciting feature that we introduced this year called fee bump transactions. Fee bump transactions enable two main possibilities. First, they make it possible to change the fee on an existing transaction. This was indeed the original motivation for fee bump transactions. So let's try to understand why this is useful. Imagine that you had an escrow account like you had in the previous slide, and you have some pre-signed transactions associated with it. When you made those pre-signed transactions, you had to choose a fee. Now, the base fee has been 100 for a long, long time. But maybe you were really forward thinking and you thought, well, like in a bad case, the base fee might rise to 1,000 or 10,000. And so you decided to build your transactions with the idea that the base fee might rise to 10,000. Great, that was pretty conservative. But unfortunately, people today are talking on the Stellar Dev mailing list about raising the base fee to 100,000. If that were to happen, well, you'd be out of luck because your transactions would be invalid and they wouldn't be able to be executed anymore. So what to do? Well, the first thing to note is that this is a backwards compatibility issue associated with raising the base fee. Raising the base fee could break people who made reasonable, even conservative assumptions. Now, fee bump transactions don't fix the problem directly because the fee could still rise and your transaction could still become invalid. But rather, they give you an escape hatch by letting you just change the fee if you need to. So that was the motivation, but it's not actually the exciting thing that fee bump transactions enable. Ideally, you don't get yourself into those situations in the first place, you know? The exciting thing that fee bump transactions enable is the possibility to separate who pays the fee from who provides the sequence number. Now, this sounds like a really, really boring technical detail, but it's actually the basis for a hugely impactful usability improvement. But before we can talk about how that usability improvement works, we have to talk about how fee bump transactions work. So let's get right back into the details and talk about that. So to understand fee bump transactions, you have to understand the entire stack of transaction processing in Stellar. So at the bottom, you have operations. Operations are the fundamental unit of work on Stellar. An operation is something like a payment, changing data on account, setting options. Then you have a bunch of operations, and they're composed together into a single transaction. A transaction, either all the operations succeed or all the operations fail. The transaction also includes some additional metadata, like who's going to provide the source, who's going to provide the sequence number, what the fee will be, and what sequence number will be consumed. But we often talk informally about submitting a transaction to the network. This is kind of an abuse of language because really you have to submit a transaction envelope to the network. A transaction doesn't have signatures, but you can't do anything on the network without signatures. The transaction envelope combines the transaction with its signatures. So imagine you had this transaction on the right that you want to submit. It has signatures from two parties, from A and B. You are A, and you really want this transaction to execute. It has a lot of value to you. But B will lose out if it's executed. Unfortunately for B, you have a copy of this transaction that's signed, so you can submit it whenever you want and execute it. But B might not be as unlucky as it sounds. The reason that B might not be as unlucky as it sounds is that there might be surge pricing. And imagine that due to surge pricing, the required fee was actually 1,000. So your transaction can't be submitted. Well, more accurately, it could be submitted, but it will be invalid. So you call up B and you say like, hey, like, please sign this for me. And they laugh at you because it's bad for them and they're not going to do it. So you can't change the fee. And so now you say like, oh, come on, I'll pay you to do this. Come on, do me a favor. But B is really spiteful and they just refuse. You're kind of in a bad situation until you remember that you have access to fee bump transactions. And now you can save yourself. So the way that this works is basically a fee bump envelope doesn't contain a transaction, whereas it contains a transaction envelope. So a fee bump envelope actually contains two sets of signatures. The inner signatures apply to the inner transaction. And that's exactly what you had before on the previous slide. The outer signatures only apply to the outer transaction. But the only thing the outer transaction does is change who pays the fee. If you're willing to pay the fee, you can just sign it yourself and change it unilaterally. Problem solved. So far, I've only told you about how fee bump transactions can rescue you from bad situations. But the exciting part about them is actually they can become a core part of your operation, especially if you're doing a non-custodial application. So imagine that you pay fees for your clients. How would you do this historically? Well, you'd use the channel account approach, where you have a collection of channel accounts. And when your clients submit transactions, you use your source accounts, your channel accounts as the source account, excuse me. So basically, you have to tie up your own sequence numbers, but that allows you to pay their fees. If you have a lot of clients submitting a lot of transactions, you need a lot of channel accounts. This is operationally complex and it's expensive because every one of those accounts requires reserves. But today with fee bump envelopes and fee bump transactions, you don't have that problem at all. Because now you can let your clients use their own sequence numbers for the source account. You use their own source account to provide the sequence number. All they have to do is set the fee to 0. Now they know they're not going to get charged the fee. When you want to submit their transactions and pay the fees for them, you just wrap it up in a fee bump envelope. You set yourself to be the source account, and you set whatever fee you're happy to pay. So this is a huge, huge operational simplification because instead of having a gigantic collection of channel accounts, you just have one fee-paying account to manage. I like simple, so this is really exciting for me and for people who build these kinds of applications. Now, the hard thing about doing the fee bump transaction exchange was about introducing new types of transaction envelopes. Historically, there was only one type, and it was called transaction envelope. But beyond that, there wasn't even a way to add new ones. We had to be very clever to do that. Once we've done it, though, we opened the door to as many transaction envelope types as we want. So here's an example of a new feature that we could build, we haven't built yet, that would make it possible to retry transactions on the Stellar network. Right now, that's not something you can do. If you submit a transaction and it fails, it's consumed the sequence number, just the same as if it succeeded. Transactions can only be submitted one time. But that can be problematic. If you have a really, really valuable transaction and it fails, well, you're going to be really sad. And there's not going to be a lot that you can do about it because it already failed. And maybe you can get the new signatures and stuff, but probably not. So how could you fix this? Well, you could use this new kind of idea. You could make a new type of transaction envelope called a retriable transaction envelope. This type of transaction envelope, it can't be submitted on its own. But the key is that the sequence number is only consumed on success. That is exactly why it can't be submitted on its own, because it would open you up to replay if it failed. People could fail again and again and again and consume your fees again and again and again. Now, when you want to submit this very, very important retriable transaction, you wrap it up in a sacrificial sequence number envelope. And this kind of an envelope, what it basically does is what a normal transaction does today. The sequence number is always consumed. So basically, the retriable transaction contains a very, very important sequence number that you can't mess up. The sacrificial sequence number is one that you can throw away as many times as you want. It's basically a spam. So, if you fail, you just threw away that bad one, but no big deal. You can just make another one and it's no big deal. But the important one was protected and you can retry. So I have one other potential application here that I'm going to talk about very quickly. I'm not going to go into the details about this. You can look at this and try to understand what it would mean. But basically, it's a type of envelope where you can sign for specific operations instead of signing for the entire transaction at once, which is how transactions work today. Now, the reason I'm talking about something like this is because it's highly related to some Stellar ecosystem proposals that are going to be discussed later this week, namely the recovery signer server that Lee is going to talk about on Wednesday, and the Turing signing server proposal that Tyler is also going to talk about on Wednesday. And I recommend you go to those talks. I'm sure they'll be extremely interesting. I'm not going to talk more about those, but the key observation is that those proposals delegate signing power to a server. And this exposes you to a problem called the confused deputy problem. The confused deputy problem is essentially a privilege escalation attack, where you instill a deputy with signing power, but the deputy might not do exactly what you meant. Perhaps you have a bug. Perhaps you accepted some kind of transaction that you didn't mean to. So these new signature envelopes would much reduce the risk of that by allowing you to assign for a specific operation that you've specifically identified, rather than signing for the entire transaction at once. This could greatly improve the usability and power of those kinds of proposals. So with that said, these are things that we could do. And I hope that they've inspired you to think about what the future of the protocol might be. So I just want to say thank you for tuning in, and I'm happy to take some questions now.
Awesome, John. That was great. Super interesting. I think that that's just a dimension of Stellar that a lot of people don't have a lot of experience with or access to. Meridian out there. John's going to take questions for like the next 10 minutes. We'll get in as many as we can. You can submit your questions via the QA box on the top right of your screen. John, you ready?
I am ready.
Okay, so the first one comes from Rahim. It is, can the claimable balance operation also be used for retrying payments? Or follow up, or can claiming also fail?
So both of them can fail. Like create could fail because of the state of the sender account. It's impossible to avoid that. Imagine I tried to send $100, but I didn't have $100. And claim could also fail because imagine I tried to claim it, but I didn't have a trust line for dollars. It's not going to work. But the idea behind this, where you could get retriability, is if, for example, the creation of it is something very important that you have to get right, and so you know that you're set up to do it. But the claim is something that you don't have to agree to in advance. Once you've made the payment, you can just submit the claim whenever you want. And so this kind of gets you a retriable payment mechanism where if you mess up claiming it, you just try again, no big deal. So it's a little bit weaker than something like a generically retriable transaction, but it's still a lot more powerful than where we are today.
Great. I have one from Corey, which is, how do you decide which features to add to the protocol?
That is a good question. And it's a very kind of open-ended question. So I try not to think too much about what I think would be really, really cool. The things I told you about today are things that I think are really cool, but they're not necessarily things that we're going to do. And the reason that I try to separate what I think is really cool from what we should actually do is that a lot of times doing something that's not cool is a lot more impactful. Like right now, there's this discussion about this this clawback cap, which I think it was proposed by Dan Donnie, I might be saying his name wrong, of Securrency. And like,
can you tell us a little bit about what you mean by a clawback cap?
Yeah, so cap is the word for a proposal for changing the protocol. And clawback here, clawback is basically like an issuer has a regulatory requirement to be able to recapture funds that an account that a holder owns. This is true in some jurisdictions. I'm not a legal person, so I don't know which ones. But the point is that this is an important feature for meeting regulatory requirements. It's not really that cool, like if I tried to sell it to you, you wouldn't be necessarily that excited. But from an impact perspective, it's probably more impactful than most of the things that we spoke about today, because meeting regulatory requirements is hugely important for making Stellar the kind of great success that we know it can be. So a lot of times when we're trying to choose what to do, we're trying to choose things that we either need to do in order to solve some issue. And that, for example, was like the motivation behind fee bumps, where we knew we had this backwards compatibility issue and we had to fix it. So how could we fix it and do something good at the same time? Or we try to do things that are going to be really, really impactful.
That makes sense. Another sort of general one from Arturo is how long does it take to, I think, how long does it take to implement one of these ideas or to make one of these changes to the protocol?
Oh, it varies a lot. Our general timescale is like, between protocol releases, it'll be several months between agreeing on what to do, getting the specifications exactly right, and then doing it. But different changes have tremendously different scale of difficulty. And oftentimes the things that seem easy are hard, and the things that seem hard are easy. Like the fee bump transactions change was extremely difficult to implement. I mean, I think I probably spent like 3+ months trying to get all the details right and testing it and reviewing it. And, whereas the two-part payments change, which sounds a lot more complicated, we actually implemented in like, 3 weeks or a month or something like that. So there's a lot of variety there, but it's pretty hard.
Can you tell in advance how long something's going to take, or is it always a surprise?
Sometimes I can tell that something's going to be really hard just from experience. People have suggested things to me and I'm just like, yeah, that's going to take me forever. But a lot of the times it comes as a surprise. We agree in principle about what kind of feature we want. And then when we actually go and look at the code, it's like, ooh, we didn't really account for this when we built it. So there's all these changes we have to make just to be able to get the right pieces into the right spots and build the right pipes so we can get the information into the right spots and get all the security implications right. So it can be really hard to guess.
I mean, I imagine you must be careful as you make these changes. Is that true?
Yeah, that's probably the biggest impact on how long it takes is just, we are being excessively cautious about not opening up any security issues when we do this and not creating any vulnerabilities or bugs or anything like that. And that starts right from when we're designing it, and it goes through to when we're implementing it and we're thinking about like, okay, these are the things that we need to have in place, the checks and balances we need to make sure that everything's going to be safe. But then even once we've done that, we test very heavily. We probably spend more time testing the changes we make than we spend actually writing them, because there's so many possibilities, and we want to make sure that we didn't leave anything unhandled. The security of the Stellar network is much more important than introducing a new cool feature. If we introduce a cool new feature but break everything, well, that wasn't much good at all.
Makes sense. Very specific question from Lee. How many times can you fee bump a transaction?
That is a kind of tricky question to answer. So the first thing I'll say is you cannot put a fee bump inside of a fee bump. So in principle, you can only fee bump a transaction one time. But the thing is, like, let's suppose that there was surge pricing and you tried to fee bump a transaction and its fee was originally 100 and it was surge pricing at 1,000 when you observed it. And so you tried to fee bump it at 1,000. But then by the time that actually got submitted, the first surge pricing had actually risen to 2,000. Well, what you could do is just submit a new fee bump transaction, totally separate, that wraps the same inner transaction, but goes to 2,000 instead of 1,000. So in principle, you can do as many fee bumps as you want, but you can't chain them together.
Interesting. Okay, I think we have time probably for one more question, and it's from Anthony. What is your favorite little known feature in Stellar Core?
Oh, interesting. What is my favorite little known feature?
I mean, Anthony asked little known, but maybe you could just say feature, or is there some little diamond that you can extract from your knowledge of Stellar Core and be like, here world, this is cool?
I mean, there's so many cool things I could tell you, but things that are cool to me aren't necessarily cool to other people. But I don't know. I think that bump sequence, which is a really, really kind of obscure operation that probably most of you have never ever encountered, is probably one of these very cool Stellar features that people don't really use. Bump sequence is this, like, basically what it does is it takes the sequence number of an account and instead of increasing it by 1, it increases it by whatever you want to some higher number. And the reason that you might want to do this is if you have a protocol where you have a bunch of transactions and you have different branches in your tree, you might want to jump into the future to invalidate a whole bunch of transactions. So this is a really, really useful contracting tool. But if you're not contracting on Stellar, you're probably not using this.
Makes sense. Perfect. I think that's all we have time for right now. John, thank you so much. I mean, it's always revealing to see exactly how these things come together and exactly what they mean. And I personally have been looking for a way to cover Lumen reserves and transaction fees for a long time. So I'm very excited about these new features that are introduced in Protocol 15. Again, reminder to everyone, that vote is on Monday. Update your software. I think afterwards, it's going to be a lot easier to build user-friendly apps and services on Stellar. This is what I think. Meridian, if you have thoughts on that session, please do share them in the right-hand bar called Session Feedback. We'd love to hear from you. And now it is time for another break. So stretch your legs, hydrate, and in about 10 minutes, we'll be back with our next session, Vibrant, putting Stellar's latest features into practice, which is pretty much the perfect follow-up to the talk you just heard, because it does show how the changes John described were implemented in a user-friendly, consumer-facing app. So enjoy the break, but don't go far, because I'll be back in a few minutes with the next quiz.